Hi, this is Synthchaser with Synthchaser.com. We're in the process of repairing this ARP Pro Soloist, and we've got to the point where we have determined that the filter VCF Submodule, this 4034, is dead. We verified that there's a signal being passed in, there's a proper control voltage being passed, it's being powered properly, but there's no output. So we need to repair this submodule, and it's going to be a challenge because, for starters, the module is encapsulated, so it's sealed in a plastic case and filled. Early ARP submodules were filled with epoxy, making it virtually impossible to get in there and service them. This is a second generation submodule, so it should be a matter of just cutting this open, removing this plastic cover, and then it should be filled with silicone, like a caulk inside. And then on the bottom it's probably an epoxy base. So we need to get this module off and then decapsulate it. So that's challenge number one. Challenge number two is someone had worked on the board before. I don't know what they were doing because maybe they swapped the filter module, but they managed to destroy many of the traces. There's some nasty flux residue there. Hopefully it's not acid core flux that's been sitting on this for however long. But basically, since they destroyed the traces and pads, it looks like they put little bits of wire and huge globs of solder over that to repair the traces. So we're going to need to take this module off to decapsulate it, put it back in to test it and troubleshoot it, remove it again to repair it, and then put it back in again for proper operation. So this board, which is already pretty damaged, is not going to stand for that. It's not going to survive that many rounds of desoldering and soldering. Plus, it's going to be difficult to resolder to it because of the damage that's there. So we're going to come up with a creative solution to basically make this VCF submodule have a connector that connects to the board, so we can easily connect it and disconnect it to service it. So we're going to start by desoldering this from the board C. So I'm going to remove to desolder this, and we'll see what it looks like once we get it off, and what kind of state the board is underneath. So I've got the 4034 submodule off, and there was from the prior work, there was a lifted pad here, although this wasn't connected to anything. And then there had been little bits of wire that had been replacing damaged traces, like this one here, and they came up and apart when coming off. This was one that they had put a jumper wire to connect a damaged trace. Here's another one that had a little bit of wire attached to it because they had lost the pad previously. So we're going to clean this up and see what we're left with. It's okay. Also, because of the damage to the board, it was necessary for me to cut the pins on this from the top to get it off, because I couldn't get it desoldered from the pads on the top of the board. But that's okay, because this module isn't soldering back to those pads anyway, so we're going to make a new connector for this to work around the damage that was there. So I'm going to clean this up and we'll see what we're left with. On the top side of the board, things are looking pretty reasonable because the guy didn't get his soldering iron there, probably. There's one pad here that's connected to something, and that looks okay. There's a lifted pad here, but it doesn't connect to anything, so that's okay. Another lifted pad here that doesn't connect to anything, so it's okay. And then these ones down here that are connected to traces, they appear to be okay. So on the top of the board, we're actually looking pretty good. It's the bottom of the board where the last guy put his soldering iron that we have some problems. So this pad here is gone, but it wasn't connected to any traces, so that's okay. Its connection's at the top of the board. This trace has lifted a good amount of the way back, and this is some wire I think he's replaced it with, but the pad there is gone. This pad here is workable. This pad is damaged but workable. This one, again, the wires come off, the traces come off, and it was replaced with a bit of wire. This one, there's two traces that meet up. The pad is gone, and the wires, the traces are kind of dangling there. There was a piece of wire there. This one, I believe, just goes through, so there's no trace coming off, but the trace here is gone. And this one, actually, it appears to be lifting, but it appears to be workable. So there's a bunch of damaged pads and traces on the bottom of the board, and since we need to reinstall this module twice, we're gonna put a connector here that we can connect the module to. So once we repair this damage to the circuit board, no one ever needs to touch it again. But the next step, the first step, is to actually open up this submodule and get inside of it. So you can see that there's a thin plastic wall here that runs around the board. So basically there's an epoxy coating here, a layer of silicone goo, and then the circuit board is at the bottom. So we want to get this plastic case off, and we're going to do something fun to get it off. So stay tuned. So for a delicate job like this, we're going to use some delicate tools like this very precision saw. And what we're going to do is we're just going to shave a tiny bit of the plastic off the side. And we're going to pick the side because the circuit board goes all the way up to the side. This one, the pins are right up there, so we know that the board is right there. We're going to pick this side, which the pins are set back a little. Well, let's pick this side. And again, I'm just going to shave a tiny bit of the plastic off. So I've started to shave the plastic, and I can notch a little bit more off this time. And this time I have managed to cut inside, and you can see the silicone there, and there's the circuit board. We cut up right up against the side of it. So now I'm going to try to see if I can peel this back with some tools and pop this off without doing another cut. Or just for good measure, while I'm here, I'm going to do one more cut. So just a little shave, better conservative than not conservative. And here I've cut in, and now the plastic cover comes off without any problem. I can peel this epoxy off, and then I can take this in and finish decapsulating it. So I've managed to get the plastic cover off by sawing the two sides off, and I've managed to remove it without damaging the circuit board. As you can see, the circuit board comes right up to the plastic, and there's traces that run right at the edge of the circuit board, so it would be very easy to damage that. So it's a good thing I use such precision tools to make this cut. So what we're left with now is the circuit board with a layer of silicone, like a caulk, and then a hard layer of epoxy. this layer of silicone that was on the bottom between the plastic and the circuit board just came off, just peeled off. This we're going to have to remove this epoxy to get to the next layer of silicone there. So for that we're going to use some old wire cutters. I'm not going to use my good ones that I would use on a circuit board, but I'm just going to use some heavier duty ones, and I'm going to just kind of chip away, break away at this, and looks like eye protection is going to be a must. So just carefully chip away at this, particularly around the pins if you're planning on remounting it using the pins, because the traces were damaged on the board. I had to cut the pins to get it off, and because the traces are damaged, I'm not planning on remounting it with these pins. I'm going to build a special connector, custom connector, just to mount this to the board. So I'm going to go ahead and get the rest of this epoxy off, and then I'll show you the next step. So the key seems to be releasing it from the pins, and once you do that, a big chunk of material will come off in the center. But you do need to be careful when you cut. I mean, there are some ceramic capacitors here that are poking up above the level of the silicone. So the next step is going to be to try to get the silicone out. We might have to just, with an X-Acto knife, carefully work little bits out. But I'm going to try to go along the bottom and see if I can release it somehow from the circuit board and pull it off as a big glob. The issue is you don't want to cut any traces. You don't want to cut any component leads. So you don't want to damage any components. So yeah, I mean, this is I'm going to try to release it here along the bottom. But I'm pretty sure it's not just going to come off in one chunk. Hopefully my hand isn't blocking the camera. So yeah, that's not going to come off in one chunk, so I'm going to have to just work it out bit by bit like this with the X-Acto knife. Again, being very careful not to damage components as I get to them. And it's difficult because you don't know where the components are and when you're going to get to them. So I'm going to work a little bit on it, and I'll update you on the progress. So I made very little progress here. This is it's really wedged in there, and it sticks pretty firmly. It takes cutting and pulling to get this stuff to come off, and it just kind of crumbles off. It doesn't like pull off in a big sheet like we were fortunate enough with the stuff on the bottom. So I've exposed some components. There's a resistor, a capacitor, some transistors. I think these are the Mosfets. There's an IC there. Here's the temperature compensating resistor, the TempCo, that keeps this module temperature stable. So I'm going to keep carefully working at it. I might also get some dental pick type tools to work this out. But need to be very careful with cutting and scraping on this, because there are traces on the component side of the board. On other ARP submodule, like the 4075, the traces are just on the bottom of the board, and this is a double-sided board. So we need to be very careful not to damage these traces when we're trying to cut and scrape this caulk out. So I'll check back with you after I make a little more progress. So I've been making progress here. I've got the main shape of the board. You can see the tops of most of the components now exposed and the crumbly silicone mess left behind as I've been working it out. I've been carefully probing around with an X-Acto knife, and then to get between leads of components or in fine areas, a dental pick tool, being careful not to scrape the traces or damage the components. But I've exposed the main outline of the board and the components, and see there's these 4 large ICs. These are CA3086 transistor arrays. There's 5 transistors on a single substrate. These are used for the exponential converter and the ladder filter, since this is a copy of the Moog ladder filter. There's the 1.87K temperature compensating resistor. It's an unusual value. I heard that ARP somehow acquired some surplus of them and designed things to use that value. It's very difficult to find, and I've actually had a batch manufactured, and I have them for sale on my website. This is what keeps it temperature stable. So if you have an ARP that's drifting, or has a filter that's drifting, or an oscillator that's drifting, it could be the temperature compensation resistor. So that's something to check out. Here's a pair of Mosfets transistors. You can see that they have a paint on the top. It's because they're matched transistors. There's a couple of little red blobs poking out here. They're tantalum capacitors. So we're going to want to change those while we're in here, since that's one thing that we remove from everywhere in the synthesizer. And here's an op amp. It's the same op amp that's found elsewhere in the synthesizer, and it's prone to failure. We've replaced a couple of them in the synthesizers that we've been repairing in this video series. And so I would suspect this is a likely suspect, maybe the first thing we're going to check when we get this all back together. But we're going to continue to clean this up until we can actually test these components with the synthesizer powered on. So I'll continue picking away on it. I've been carefully probing with the X-Acto knife, being careful not to damage any components or traces on the circuit board. I can also use this dental pick to get in between fine areas, again being careful not to damage anything. So even though I used a miter saw on this earlier, now I'm being super careful for reals, because I don't want to damage anything as I'm clearing this silicone out. So I'll work on it some more and show you what it looks like. So it's taking a lot of work, but I'm getting there. I'm getting these components to the point where I can probe their leads and identify the components, the different resistors, and get to the leads of the ICs. So I've got about a little bit left on the lower half here to do, and then we can reconnect it. Now I've got the submodule nearly completely cleaned out of the silicone. There's still some between the legs of the chips and in some of the leads of resistors and other little components. But that's okay. What I really was trying to do is not to make this perfectly cleaned of the silicone, but to get it so where I could identify all the different components that are there, the resistors and what their values are. Because there's no published schematics for these submodules, and there's a website that has someone reverse engineered these and posted the schematics, but there's no board layout for this. So like I'd have to take a look, is this since there's 4 of the same chips, which one is which? So I do need to see, what connects to what, and I need to get access to all the legs of the components so I can touch them with the oscilloscope and troubleshoot this component. So as we saw, the board C, where this solders in normally through these pins, goes down and pushes into the board and solders in. The traces and pads there were all damaged. So we need to put this back on to troubleshoot it. We need to take it off again to repair it, and we need to put it back on to restore the keyboard to working condition. And it's not going to hold up for that. So what I'm going to do is I'm going to make I've already made this special cable assembly. So I have a 16-pin cable, the same kind of ribbon cable that's used in the synthesizer. I sell replacements of these on my website, synthchaser.com. And what I've done is I've cut one of the male sides off, and I've soldered with little bits of heat shrink a dip socket. So what I'm going to do is I'm going to cut this in half, and then I'm going to solder individual wires to the 10 places on the circuit board where these connect, and I'm going to solder on the other side. I'm going to solder 10 wires to the pins that were coming off of this board, and then I'll be able to connect and disconnect the submodule very easily with this connector. Then I won't need to do any soldering beyond that initial soldering to get this in and out when we need to. I don't know why these were soldered, why they made the decision to solder those to the board in the first place. They're not really designed to be serviceable. Obviously they're enclosed in plastic and filled with stuff that you weren't meant to get apart. And it's not just because they were infringing on Bob Moog's ladder filter patent here. They were doing this from their very first modules used in the ARP Soloist, not the Pro Soloist, but the Soloist, and the ARP 2600. Eventually with the 4075 submodule that's found on Omnis and later Odysseys and Quadras and Avatars, they didn't encapsulate them, so these modules are just soldered on the board like this, and you can poke the back of them without even removing them from the circuit. So yeah, these weren't designed to be serviceable. This one has a date code of 1975, so this has been sealed up for over 40 years, and it was never meant for us to see what was inside, and now you're looking at it, and we're going to repair it. So I'm going to solder this cable connector that I built to the board and to the submodule, and then we'll troubleshoot the submodule and find out what's wrong with it. I've soldered the wires of the ribbon cable to the board where the VCF submodule plugged in. I've taken care to make sure that there's connections on the component side and the back side of the board where it was necessary. In some cases where the traces were damaged, I actually soldered them to the top of the board where the traces would run to these vias. I tested through the dip socket here that all the pins are making contact to where they should. And what I'm going to do so this doesn't flap around and so this can be covered up and secured is I'm going to cover this with electrical tape. It's kind of cheesy, but there's no way to mount standoffs here. They use every single fraction of a millimeter on this board, so there's no way to install some standoffs here. But what we're going to do is we're going to cover this area with electrical tape, and then we're going to put the VCF module right here with the component side facing up, and then the cable will come off and plug in here. So I'm going to cover that up, and then I'm also going to connect the male half of this cable, which I have here. I'm going to connect the male half of the cable to the pins of the VCF module, and then we'll be able to connect it and get testing. So it took a bit of time to get into it and then get it set up with a socket. But on the board C now we have an IC socket here that we can plug the filter into. We've removed the filter, taken it out of its case, removed the epoxy, removed all the silicone, and we're able to probe all the parts of this. We've connected it to a male plug that we can plug into the socket. We've created a space here that we can set this down for testing where it's not going to short up against anything. And now we can plug it in and troubleshoot it. So with the filter exposed, now we can troubleshoot it. And the first thing that I'm going to check is the op amp. Since we have so many op amp failures elsewhere in the synthesizer, that's going to be the first thing that I check out. So I am going to check the non-inverting input first. So there's a small voltage present there. When I press the key, you can see it moves. Now I'm going to check the inverting input. So there's no voltage there. When I press a key, it dips a little bit negative and then bounces back, equilibrates around 0. Now I'm going to check the output. The output there is 0, and when I press keys, nothing happens. So it looks like the op amp is bad. So we're going to replace the op amp, and then we're going to test it again. So I've taken the op amp out from here, and you can see this is a double-sided board, and this does have a trace on the top of the board that's connected to the op amp. What I'm going to do is I'm going to socket this to make it easier to repair in the future, and to make sure that the circuit board doesn't get damaged if someone in the future does a repair there. It'll also make it easier to test if this connection is being made on the component side of the board. Changed the op amp on the 4034 submodule, and I've connected it back in to board C, and I'm going to probe the output to the VCF module. And as you can see, we're getting that sine wave that we were looking for originally when we determined that the VCF was bad. So that's an encouraging sign. I'm going to press some keys on the keyboard. And what do you know? We are getting flute noises out of it on the flute voice. So our repair to the submodule was successful. In this video, we removed the encapsulated 4034 submodule. We broke it out of its casing with a saw and some careful picking and cutting. We were able to troubleshoot it and identify the component on there that was bad and repair it. We built a connector so we can get it on and off board C easily for future service and for this repair. So there might still be more repairs to do to this keyboard. I'm going to go through and test everything now that I'm getting output, and but that'll do it for this segment of the video where we were repairing a filter submodule. And please continue watching, and you'll see the finished product when we complete the restoration of these two ARP Pro Soloists. Thanks for watching.